Woohoo! Welcome back. Today we're going to be working with integration by parts, part 2. Woo! And Square Bear is here to help me because Square Bear is very good at breaking things down into parts. When we last left our heroes, we're waiting for the rain. It hasn't started yet, but I am told any minute now. So there's about to be great excitement here and possibly 2 small cats running in very wet. So we will have to see. I know there's a lot of excitement here. So we were talking about integration by parts. Let me remind you that that's this guy. And basically it says if you start with something that's difficult to integrate, you can use this formula to pull out something that comes out of the integral, and then you can reverse what's going on in the integral. So it's kind of like that Uno reversal card. You mean like, haha, you think I'm stuck. I'm not stuck. You're stuck. So in order to go forward, we probably should discuss some strategy. And the strategy is that we want to figure out which part of the integral gets easier when you take the derivative. So these are the functions that simplify when differentiated. So powers of x, x squared, etc. I'm going to move, pardon me, Square Bear. So for example, when you take the derivative of x squared, you get 2x dx, right? You know, I'm going to stick with this, but this is a little bit off the way I wrote it. So just don't tell anyone, but you know what I'm talking about. When you take the derivative of this, you know, it's bugging me too much. It's bugging me too much. As you know, the dx is very important, and I don't want to write anything that's going to be confusing for you guys. So let me just write that. X squared gives us 2x dx, and that gets simpler because we started with x squared and we ended up with an x. Coefficients, numbers out in front, no big deal. Now, natural log of x, do you guys remember what the formula is? Natural log of x, when you take the derivative, becomes dx over x. Now, is that a simplification? Yes, because it's a power of x. And so that is, in a lot of cases, going to be a lot simpler to deal with. Integration with natural log can be very uncomfortable. So this will be a good technique when you see natural log running around. Next up, so these guys are all going to be choices for you. Choices for v or dv are going to be things that don't get better when you take the derivative. So what do I mean? Cosine and sine, right? What happens when you take the derivative of sine of x? You get cosine of x. And when you take the derivative of cosine of x, you're back to the opposite of sine x, and so on and so forth. So they just flip-flop, but that never gets any simpler. It just goes back and forth. E to the x, very famously, oh my gosh, it's not even going to budge. And of course, I wasn't paying attention, so we've got some dx's. Take my word for it, there's some dx's in there. Okay, so far so good. Woohoo, you guys are awesome. Okay, Square Bear. Square Bear is hungry, would like to eat something, but thankfully there are no twins here, so Square Bear won't be tempted. Okay, shall we do another problem? Woohoo, let's do another problem. So next problem up, the integral of natural log. Now, this is the problem with chapter 7. You're going to see integrals and you're going to say to yourself, well, of course I know how to integrate natural log, don't I? And the answer is, actually you don't. You know how to integrate if you have dx over x, that integrates to natural log of the absolute value of x plus c. Oops, let me get that in the picture. So you do know how to integrate to get natural log, but believe it or not, we've never shown you how to do natural log inside an integral. And to be fair, you guys knew well enough not to ask, right? You're like, yeah, if you're not going to show it to me, I'm not going to go looking for trouble. Well, Now we're looking for trouble. So let's talk about how to deal with this. So what are we going to do? We've got a natural log. So what I'm going to do is I'm going to let natural log of x be my u. And I'm going to let just the simple dx be the dv part. And a lot of times people get very nervous about that because they're like, well, if it's dx, when you antiderivative, right? You end up throwing another x, so you're actually making it worse. And the answer is yes, but since we get the derivative of natural log becomes 1 over x, and I should write in dx, then they're going to cancel out. Do you see how that works? They're both in the same language. This is a power of x, and this is a power of x. And as long as we've got two powers of x, then we've got an integral that we can calculate pretty easily by hand. Okay, so remember that what it means is you take the two upper level, the two antiderivatives, the u and the v, and then you subtract. Remember, the original is u dv, and this becomes v du. So we take the u and the v, like that, and then we take the integral of the v, which is x, times du, which is 1 over x dx. So that's going to be x natural log of x minus, now look what happens. X and 1 over x cancel out, so we just get 1 dx. So we get x natural log of x minus, what's the integral of 1? X. And then remember that you're plus c at the end, which is the bane of everybody's existence. And it turns out some people do memorize this formula. So this is what the integral of natural log is. It's x natural log of x minus x plus c. If you feel like, you can go ahead and memorize that. It's up to you. You can also learn integration by parts and just use that. Okay. So again, I'm going to encourage you, because now I'm going to do some interesting trickery. It's pretty fun, but it is very simple to get lost. The steps I'm going to use in the next couple problems are a lot. And so I'm really going to encourage you to pause this video right now, go do some homework, really learn, figure out what the heck is going on with this u and the v and the v and the du and the u and the dv and all that. Get it all sorted in your head before we start the next one. I will wait. Okay, go ahead. Go do your homework. Woohoo. You know, maybe get a snack first. Get some hydration. You know, tell somebody you love them. That whole thing. Tell yourself you love them. That's a good place to start. Okay, go ahead. I'm waiting. Okay, all done? Woohoo! Yay! Okay, so you guys ready? Dum dum dum! You guys can't always see the whole page, but you know when I leave the whole page blank, we've got some interesting work to do. So, notice the hint. Sometimes you have to use the technique more than once. So this is a case where we're going to get good practice with this. Now, I have also excitingly switched from x to t. Let's hope I don't forget myself in the middle of this. Let's talk about strategy. Strategy is, in each iteration, each time we use this formula technique, we can reduce the t squared by 1 power. So in the first step, we're going to go from t squared to t. And then in the second step, we're going to go from t to 1. So our strategy is going to be going from t squared down to t. That's step 1. iteration 1. And then in step 2, we're going to get all the way down to 1. So we're going to have to do this technique twice. If this were t to the 10th, oh man, then your teacher really doesn't like you because you're being asked to do the process 10 times. Super fun. I know. You're going to build character. Let's build character together. Are you ready? Square Bear's here. Square Bear doesn't necessarily build character, but you know, it's math is always useful. So, okay. So let's do step 1. I'm going t squared e to the t dt. Now notice that t squared will get better if I take the derivative. E to the tth power, really, it's the poster child for things that do not change with calculus. You take the derivative, you take the integral, it's all the same. So this is going to be my u, this is going to be my dv. So if my u is t squared, my du is 2t dt. What do you guys think? Kind of woohoo? Okay. Then my dv is e to the t dt, and so my v is just e to the t. Okay, so one gets smaller, one gets officially bigger, one goes backwards with the antiderivative, but this, it's unchanged. So the new integral is going to be u times v. So this cross combination, the t squared e to the t minus, and then remember, whatever this is, it's the reverse. Oops, sorry, you can't see that. Whatever this is, u dv, this becomes v du. So it's going to be minus e to the t times 2t dt. Okay? Okay, woohoo. So let me clean that up. T squared e to the t minus, and then I'm going to move the 2 out. And I've got e to the t times, you know what, it'll be easier if I write this slightly differently. If I write the t first, it'll be easier to see what's going on. E to the t dt. And now, second step, okay, t squared e to the t minus 2 t e to the t dt, and I'm going to go ahead and call this my u, and this is going to be my dt, my dv, sorry about that, too many letters. And my dv is e to the t dt. So I've got, and I'm going to do a great big arrow. And now this is going to be a little bit exciting. Just a wee bit exciting. I got to get some blank paper and see if I can translate this. Pardon me. So I have t squared e to the t minus 2 times the integral of t e to the t dt. Okay? And I said this was my u, and this was my dv. Here comes Square Bear. Hello, Square Bear. How are you doing? Very hungry. I understand. U equals t, so du is dt. dv is e to the t dt, so v is e to the t. Sorry about that. I wanted to write that all back. So I've got a complete copy of what I just did on the other page. So we did it twice. So now I've got uv again, so that's t e to the t minus the integral of v du, which is going to be e to the t dt. And now, what have I done? Well, in the first step, I got us down from t squared down to just a t, right? And then in this step, I got us from a t down to just e to the t. And I know that integral. The problem is that I've got a bunch of minuses I got to deal with. So let me clean this up a little bit. I got t squared e to the t minus 2t e to the t plus 2 times the integral of e to the t dt. Do you see how the minus become a plus? 2 minuses become a plus. Yep. Okay. And then I've got t squared e to the t minus 2t e to the t plus 2. And the integral of e to the t is e to the t. And then you've got a plus c. Pardon me. Now, I believe personally that the c only pops up really for us at the end. But if you would like to include the c all the way and have it 2 times c and d and all that, that's great. The point is, after all this anti-differentiation, you end up with a constant. The fact that this is still an integral tells me that I haven't popped out my c yet, but we could have a late night conversation about that. It is perfectly fine just to put a c here. And notice the other part of it is you can track the whole process, right? We start with the t squared times e to the t, then we got a t, e to the t, and then we finally popped out e to the t by itself. So 2 iterations got us to the point where we could just integrate this without having to use any fancy footwork. Okay, woohoo! You guys are awesome. I'm going to stop there because, again, we're in the realm of problems that take a long time. That wasn't too bad, 17 minutes, but I'm going to go ahead and break it up. Square Bear's getting hungry. I'm going to find him some perfect squares to eat, and I will... No rain yet, sadly, but I will see you in the next video, and I hope you're having a great day, and I hope you can take a break, maybe try some homework, maybe take a rest, get something to eat and drink, and then come on back. There's an even weirder problem coming. I really like the next one. I think is really, really cool. But I encourage you to practice this a bit and really understand this technique, because what I'm about to do is going to seem like flim flam. So I'll see you then. You guys are awesome. Math on. Woohoo.